Okay. So many are yet to join. Anyway, we can start. Okay, so we have almost finished our first module, and the last topic was moment of a force. So we have seen the basic definition, and also we have gone through some animations regarding the moment of a force. What is a moment of a force? So what is a moment of a force? So, or what you mean by a moment of a force about a point? That means you are given a force. The force is acting on an object, and usually when a force is acting on a body, what happens is the body will move towards some other point, from the initial point to a final point. So it may create a linear movement. But if the force or the direction of the force is such that it causes a rotational effect, then that particular effect or the rotational effect of the force is termed as the moment. And how we can quantify the moment of a force, or the find the moment value or the magnitude. So already we have discussed that a moment of a force contains two parts mainly. That is, the first part is the magnitude. It should have a magnitude, that is a value, that is somewhat like 20 kilonewton meter or 30 kilonewton meter. So that value, it is the magnitude of the moment. Then instead of direction, it is sense. It should have a sense. That is, either it is a clockwise moment or counterclockwise moment. That means due to the force, due to the action of the force, it may create a clockwise rotation or counterclockwise rotation. If it is providing a clockwise rotation, then it is having a clockwise sense. Otherwise, it will have a counterclockwise sense. That means, suppose this is your body and you are holding on this point, and a force is applied here. So the body will have a tendency to rotate in this fashion, like, right? So it have a clockwise moment. This is having a clockwise moment. This is the point of application, that is point B, and here point A. Then point B is the point of application of the force, and AB, it is the arm of the force. So the moment M will be equal to F into that distance AB, and this is in the clockwise direction. And if the same body A and B, the force is in the opposite direction, then what happens is it will have a tendency to rotate in this particular direction, or in this sense, that is counterclockwise sense. Counterclockwise sense. Here also the moment is M equal to the force into perpendicular distance. Force into perpendicular distance AB. So this is the moment of a force. So it is a measure of rotational effect of the force, and it is defined as the product of magnitude of the force and the perpendicular distance of the point from the line of action of the force. Okay. Now, this is the force, that is, let this will be a force F acting on a point A. Okay, here you are considering a point O about which the moment is to be found out. Let it be inclined, this force inclined at an angle theta. Okay, and the point A where the force act is termed as the point of application. Okay, point of application. Point of application. And here you can see the dotted lines. This is the line of action of the force. Line of action. Line of action of the force. Okay. Now, the perpendicular distance from the point. This is not the perpendicular distance, but the dotted line, this particular point, that is OB, let it be B. So, this OB is the arm of the force. This is the termed as the arm of the force. Arm of the force. Okay. Arm of the force. So, this is the point O and this found out. So, this particular point O is termed as the moment center. Moment center. Okay. So this is about the moment. Now, in order to do the problems and all, we have to consider this thing. That is, suppose in this problem itself, you are having a point O about which you have to find the moment, and the force is given here. Let it be okay, F itself, F. And if the perpendicular distance is known, perpendicular distance D is known. If it is known, then you will get the value M equal to F into D. But suppose if the force is like this, that is, this is the moment center O, and here it is given distance D, but the force is acting in an inclined direction, that is theta. Then moment is equal to M equal to force into perpendicular distance, but the perpendicular distance we don't know the perpendicular distance. This is only inclined. So the perpendicular, in order to find the perpendicular distance, you have to choose the line of action, right? And the line of action, the perpendicular distance is the distance of the point, that is the moment center, from the line of action. That is, it will be somewhat like this. This is the perpendicular distance, actual perpendicular distance, that is, let it be D1. So, F into D1 we have to find, but we don't know the value of D1. D1 is unknown. We only know the value of D. So, in that case, what we are doing is, we are choosing, let it be A, resolving this force. We are resolving the force, this particular force F, into two components, that is the y component and x component. So you will split the force into two, and separately you will get two moments. First one, the moment due to the vertical component, and also the second, the moment due to the horizontal component, right? So we'll see how we'll do that. Okay. So suppose this is the moment center O, and here is the point of application A. The force is acting like this. This is force F. Okay. Now, and it is given that it is acting at an angle theta with the x-axis. So what we have to do is we will split this force into two. That is, we'll find the two components. That is the x-axis. So we have to resolve the components along the x and y axis through the point, that is the point of application, that is A. So at the point of A, the two components will be directed in which directions? If the force F is like this, then the two components will be acting in this particular directions, right? And this is cos theta, and this is F sin theta. Okay, this should be in mind. So at the point A, the x component will be like this. The force in this particular direction, that is F cos theta, and the y component will be F sin theta, right? ഇതുവരെ എന്തെങ്കിലും സംശയമുണ്ടോ? ഇതുവരെ കിട്ടിയതിൽ regarding the moment of a force. ഒന്നും പറയുന്നില്ല? No. Okay, fine. Now, suppose the okay. Suppose this is the line of action of the force, and let this be the vertical distance. This is D, which is unknown. We don't know the value this D1 or D. We only know the value OA. Okay, we are dealing with the moment of the force, and we know only the value of OA, and the value OB. OB is unknown. So usually the moment is given by m equal to F into D. It should be like that, F into D. And by seeing that, you can see which type of moment is that. What is the sense? Either it is clockwise or counterclockwise. എന്തായിരിക്കും? ഒന്ന് ആലോചിക്കാൻ പറ്റുമോ? ഇതെങ്ങനെയായിരിക്കും? ക്ലോക്ക്വൈസ് ആയിരിക്കുമോ കൗണ്ടർ-ക്ലോക്ക്വൈസ് ആയിരിക്കുമോ? That is, you are having a body like this. ഇതിപ്പം O A എന്ന് പറഞ്ഞത് എന്താണ്? These are the points on a object. Let it be an arbitrary area. ഇതുപോലെ ഒരു ഏരിയ ഉണ്ട്. ഇതിലെ രണ്ട് പോയിന്റ്സ് ആണ് O and A. Okay, we are holding in this point O and giving a force like this. അങ്ങനെയാണെങ്കിൽ ഇത് എങ്ങനെയായിരിക്കും റൊട്ടേറ്റ് ചെയ്യുക? either it is clockwise or counterclockwise. ക്ലോക്ക്വൈസ് ആയിരിക്കും റൊട്ടേറ്റ് ചെയ്യുക, കൗണ്ടർ ക്ലോക്ക്വൈസ് ആയിരിക്കും റൊട്ടേറ്റ് ചെയ്യുക. വി ആർ ഹോൾഡിംഗ് ഇൻ ദിസ് പോയിന്റ് O. O എന്ന് പറഞ്ഞ പോയിന്റിൽ നമ്മളിങ്ങനെ പിടിച്ചേക്കാണ്. Oയ്ക്ക് അബൌട്ട് ആയിട്ടാണ് റൊട്ടേറ്റ് ചെയ്യുക. either it is clockwise or counterclockwise. ഇങ്ങനെയാണോ റൊട്ടേറ്റ് ചെയ്യുന്നത് അതെങ്കിൽ ഇങ്ങനെ ആയിരിക്കും റൊട്ടേറ്റ് ചെയ്യുക, ഏതെങ്കിലും ഒരു തരത്തിൽ റൊട്ടേറ്റ് ചെയ്യും. ഓക്കെ, എയിൽ ഇങ്ങനെ ഒരു ഫോഴ്സ് കൊടുത്താൽ ഓക്കെ റൈറ്റ് ക്ലോക്ക് വൈസ് ആയിരിക്കും റൊട്ടേറ്റ് ചെയ്യുക അല്ലേ, ക്ലോക്ക് വൈസ്. ഇനി നമുക്ക് നോക്കാം, ഇവിടെ രണ്ട് ഫോഴ്സ് ആക്ട് ചെയ്യുന്നുണ്ട്. ദാറ്റ് ഈസ് ഓർ we are splitting the force F into two components. That is, we are resolving into two components, one along the y-axis and another along the x-axis. The y-axis component ആണെങ്കിൽ അതിൻ്റെ പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് തന്നെയാണ് OA അല്ലേ. അപ്പോൾ y എന്നുള്ള ഫോഴ്സിൻ്റെ മൊമെൻറ്റ്, അതായത് മൊമെൻറ്റ് ഇൻ ദ x ഡയറക്ഷൻ ഇരിക്കട്ടെ, moment of a force due to the x component in the moment of force, അതായത് F cos theta, this one അല്ലേ. ഈ ഫോഴ്സിൻ്റെ പ്രത്യേകത എന്താണ്? ഇറ്റ് ഈസ് ആക്ടിങ് ത്രൂ ദ ലൈൻ ഓഫ് ആക്ഷൻ അല്ലേ. അപ്പോൾ ഓർ ദ ലൈൻ ഓഫ് ആക്ഷൻ ഈസ് പാസിങ് ത്രൂ ദ മൊമെൻറ്റ് സെൻറ്റർ. നമ്മൾ കൺസിഡർ ചെയ്യുന്ന പോയിന്റ് ആണ് O, ദാറ്റ് ഇസ് എ മൊമെൻറ്റ് സെൻറ്റർ. ഓക്കെ, ഈ മൊമെന്റ് സെന്ററിൽ കൂടെ പാസ് ചെയ്യുന്ന ഫോഴ്സ് ആണ് F cos theta. So the F cos theta or the x component of the force is passing through the, or the line of action of the force, that particular force passes through the moment center. അങ്ങനത്തെ ഫോഴ്സുകളാണെങ്കിൽ അവിടെ മൊമെന്റ് എന്ന് പറയുന്നത് 0 ആയിരിക്കും, അല്ലെങ്കിൽ റൊട്ടേഷണൽ എഫക്റ്റ് 0 ആയിരിക്കും. കാരണം എന്തായിരിക്കും? ജസ്റ്റ് ഒന്ന് ആലോചിച്ച് നോക്കുക. സപ്പോസ് യു ആർ ഹാവിങ് എ ബോഡി ലൈക്ക് ദിസ് ഉണ്ടല്ലേ. അപ്പം നമ്മൾ കൺസിഡർ ചെയ്യുന്ന പോയിന്റ് ഇതാണ് O. ഇവിടെ നമ്മൾ ഹോൾഡ് ചെയ്തിട്ട് അവിടെ തന്നെ നമ്മൾ ഒരു ഫോഴ്സ് കൊടുക്കുകയാണ്. ആ പോയിന്റിലേക്ക് ഒരു ഫോഴ്സ് കൊടുത്തു കഴിഞ്ഞാൽ അത് റൊട്ടേറ്റ് ചെയ്യുമോ? റൊട്ടേറ്റ് ചെയ്യത്തില്ല അല്ലേ. അതേസമയം കുറച്ച് നീക്കി ഈ വല്ല പോയിന്റിൽ വല്ലതും കൊടുക്കുകയാണെങ്കിൽ എന്താണ്, ഒരു റൊട്ടേഷൻ പോസിബിൾ ആവും അല്ലേ, റൊട്ടേഷൻ നടക്കും. അതായത് ദ ഫോഴ്സ് ഓർ ദ മൊമെന്റ് due to the force whose line of action passes through the moment center will be 0. അപ്പോൾ ഇവിടുത്തെ ഫോഴ്സ് എന്ന് പറഞ്ഞാൽ എന്താണ്? ഇത് 0 ആണ്. അല്ലെ തന്നെ നമുക്കറിയാം എന്താണ്, ഈ ലൈൻ ഓഫ് ആക്ഷനും ഓയും തമ്മിലുള്ള പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് എന്താണ്? 0 അല്ലേ. അപ്പോൾ F into 0, F cos theta into 0 എന്ന് വേണമെങ്കിൽ നമുക്ക് പറയാം. എനിവേ ഹിയർ എന്താണ്, ലൈൻ ഓഫ് ആക്ഷൻ passes through the moment center. Okay, so to the x component is 0. Now the moment due to y component ഏതായിരുന്നു? F sin theta ആക്ട് ചെയ്യുന്നത് എങ്ങനെയാണ്? നമ്മൾ ബാക്കി എല്ലാം മറന്നോളയാ. എന്താണ്? We are having a point O and another point A and a force F sin theta is acting at a distance, this particular distance OA. So it will create a moment F sin theta into OA, which is clockwise. So this is F sin theta into OA. Okay, so this is the actual moment of the force we have to find. But the thing is, we don't know the value of D. Okay, and when we split the force into two, we will get the x component, the moment due to the x component as 0 and the y component as this particular value 5 sin theta and into OA. Now we are having another theorem, that is Varignon's theorem. Okay, we will see that Varignon's theorem, okay, which states that the moment of a force about any point will be same as that of the algebraic sum of the moment of its components. That means the main moment M will be equal to mx plus my. So the sum of this two, adding this two, you will get the final moment m. That is a Varignan's theorem, and we are using this theorem to solve the problems. Okay. So this is a Varignan's theorem. The moment of a force about any axis equal to the sum of moment of its components about that axis. That is, if you are having a force like this red one, if this is the force and it is having two components, this is F1 and this is F2. So together this one makes the force F, that is the capital F. It is the resultant of F1 and F2, or F1 and F2 are the components of F. You can define in both sense. That is, either you can say that F1 and F2 are the components of the main force F, or you can say that capital F is the resultant of the two forces F1 and F2. Anyway, the moment, suppose we are considering the moment about this particular point, O, then what is the force or the moment of the force F about the point O? F into perpendicular distance, right? So the perpendicular distance will be like this. Let it be D. So moment will be equal to F into D. Okay, and so now the moment of the force F1, one of the component of the force F, that is F1, about the same point O will be F1 into the perpendicular distance towards the force F1. That is, this is that perpendicular distance. Let it be, this is F1, so we will denote it as D1. Now for F2, you can consider the line of action is like this. So the perpendicular distance here, let it be D2. So according to Varignan's theorem, we can say the moment of the force, that is, actually it should be F into D. This will be same as that of the algebraic sum of. Algebraic sum means we are considering the positive or negative. That is, either it is clockwise or counterclockwise. If we are defining that, if it is clockwise, then we are taking it as positive, and if it is counterclockwise, we are taking it as negative. In some text, it is in the just reverse order. Anyway, we will see in this manner, that is clockwise. If it is clockwise, then we are giving it as positive, and if it is counterclockwise, we are taking it as negative. Okay. So according to Varignan's theorem, the moment of a force about any point is, that is F into D, will be equal to the sum of the moments of its components about the axis. That is algebraic sum of the moments of its components. That is, the first component is F1. So the moment of F1 is F1 into D1 plus second one, moment due to the second force, that is F2 into D2. So this is the Varignan's theorem. Okay. And you have a derivation for the Varignan's theorem that I will upload in the channel. It is very simple. Using this figure, you have to derive the relation, that is F into D equal to F1 into D1 plus F2 into D2, using certain geometrical constructions. It is simple. Anyway, I will upload that video in the channel. Okay. Now, now I think we can do a small problem on the moment of force, so it will be much easier for you. Okay, so note down that problem. I'll give you a problem. Okay, calculate the moment of a force. Okay, right here. Calculate the moment of the force. Moment of a force. F is equal to 10 kilonewton. F is equal to 10 kilonewton. Acting at a point. Acting at a point. Acting at a point, as shown in the figure. As shown in the figure. You have three conditions. When first one, theta equal to 0. Next, when theta equal to 30 degree, and the third is when theta equal to 90 degree. Okay, and the figure theta, this is point A, this is O, and the distances, here it is 5 meter, this is 2.5 meter, and this is 4.33 meter. Okay, so just take down the question. You are having three cases. Okay, so I think you have finished drawing the figure. Now, okay, you will see each cases. So the first case, you will see each cases. Okay, so the first case, that is case 1, that is theta equal to 0. Theta equal to 0. In that case, the force here the force is F is equal to 10 kilonewton. 10 kilonewton. So how the figure comes? That is, this will be like this. That is, theta equal to 0 means the force is acting like this. Okay, F is acting like this. So the point moment center is O. So moment is the product of the force and the perpendicular distance. So we have to consider the line of action through the force. So the line of action will be acting like this, right? So the perpendicular distance is എത്ര ആയിരിക്കും ഇതിന്റെ പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് പറയാമോ ഈ ഫിഗറിൽ നിന്ന് ഈ കേസിൽ അതായത് perpendicular distance of this line of action towards the point O. Yes, right, is 2.5 meter. That is, this is the vertical distance, that is 2.5. So the moment is m is equal to force into distance, that is force is 10 kilonewton into vertical distance is 2.5 meter. 2.5 meter. So kilonewton and meter, that is you will get the value 25 kilonewton meter. And this is in the clockwise or counterclockwise ആയിരിക്കുമോ? Whether it is clockwise or counterclockwise, just think. That is, you have got the body like this, a body like this, and you have a point O and another point here A, and you are giving a force like this. So whether it is rotating in the counterclockwise or clockwise direction? Yes, counterclockwise direction. Okay, so in brackets you can mention here as counterclockwise. So this is how you have to find the moment. Now the second case, that is case 2. Here theta equal to it is given 30 degree. Okay, theta is equal to 30 degree. So in this case you have to apply the Varignon's theorem, because you don't know the actual perpendicular distance. So you may split the force into two. That is, here it is O, this is A, and the forces acting are first one is the vertical component. So we know when a force F is acting like this, the vertical component will be acting like this and the horizontal component will be along this direction. And here the theta is given with respect to x-axis, right? So the x component will be cos theta. So this is F cos theta and this is F sin theta. So at the point A, a force acts like this, that is F cos theta, and the point A vertical component is F sin theta, acting like this. So F cos theta is acting at a perpendicular distance of this much, that is 2.5 meters, and the F sin theta is acting at a perpendicular distance of 4.33 meter, right? So the moment will be, so according to the sum of the two, that is m equal to moment due to F cos theta. F cos theta, moment due to F cos theta is the force F cos theta, that is F cos 30 into perpendicular distance, that is perpendicular distance is 2.5. And this is in the, whether it is clockwise or counterclockwise, it is counterclockwise direction. Okay, F cos theta, the force or the moment created due to F cos theta will be counterclockwise. So we give a negative value for this, negative F cos theta into 22.5. Now plus next one, that is due to F sin theta. F sin theta, the force is F sin theta and the perpendicular distance is this much, is the perpendicular distance, that is 4.33. So this is creating a clockwise moment, that is F sin theta. Due to F sin theta, it will create a clockwise moment. So altogether you will get a value. That is what is the value for that? ഒന്ന് ചെയ്ത് നോക്കുക, ഒരു വാല്യൂ കിട്ടും നിങ്ങൾക്ക്. ഓക്കെ, അത് ഫിനിഷ് ചെയ്തിട്ട് നമുക്ക് ഒരു കാര്യം ചെയ്യാം, അത് കണ്ടുപിടിക്കുക. നെക്സ്റ്റ് കേസ്, ലാസ്റ്റ് കേസ് ഓൾസോ വിൽ ഡിസ്കസ്, ദാറ്റ് ഇസ് കേസ് 3. Case 3, it is theta equal to 90 degree. When theta equal to 90 degree, what will be that? That you have to find. That is, ഈ ഒരു രീതിയിലായിരിക്കും വരിക. Theta 90 degree means F will be acting in this particular direction. That is F is equal to 10 kilonewton acting like this. And this is the O. Then moment M will be equal to, here you can get the perpendicular distance. നമുക്ക് perpendicular distance ഡയറക്റ്റ് നമുക്ക് കിട്ടും അല്ലേ, ഈ ഒരു ഡിസ്റ്റൻസ് ഉണ്ട്. അതുകൊണ്ട് നമുക്കതിന് റിസോൾവ് ചെയ്യേണ്ട ആവശ്യമില്ല. ദാറ്റ് ഈസ് 10 into perpendicular distance, that is 4.33 itself. So we'll get at 43.3. Unit is kilonewton meter. This is in the clockwise direction. Clockwise direction also. So ഇവിടുത്തെ വാല്യൂ എത്ര കിട്ടിയേ? Please put it in the chat box. Okay, Niharika. Are you able to follow?
Yes.
Okay.
Yes, sir.
Okay, fine. So you will get a simple value here. That is sin 30. Okay, sin 30. Okay, anyway, I think it is time to wind up. So I will take the attendance.